Hi everyone, today we are going to learn about logarithmic differentiation. So first I will introduce some of the common properties of the logarithmic functions and then followed by the differentiation exercises for you to practice. So stay tuned to the end of the video so that you can get yourself familiarized with the logarithmic differentiation. So let's start off with the common properties of the logarithmic differentiation. So what are the common properties out there? So let's say we have, for example, the first one will be ln 1 equal to 0. Second, we have ln e equal to 1. Third, we have ln e to the power of x equal to x. And then we will have number 4, ln yx equal to x ln y. Number 5, we have ln xy equal to ln x plus ln y. Number 6, we have ln x over y equal to ln x minus ln y. So do keep in mind that these are the important properties when you deal with logarithmic functions. So let's now move on to the second part, which is the logarithmic differentiation. So let's say we want to solve the example of, first we must understand the chain rule before we proceed. So what is actually chain rule? Chain rule basically states that, let's say we have function f, we will get 1 over gx multiplied with derivative of gx. So let's say, for example, now we want to differentiate ln y. So what we get is 1 over y and the derivative of y if y is a function of, if y equal to gx. So let's start off with the first exercise. Let's say we want to solve this function. Let's say we want to differentiate y equal to x to the power of x. So when you have this kind of function, the first thing you always want to do is to add ln on both sides so that I can bring forward the x to in front. So after you have this, you differentiate both sides with respect to x. So on the left hand side, we will use the chain rule that I mentioned just now. So since you are differentiating with respect to x for ln y, so it will become 1 over y multiplied by derivative of y equal to, on the right hand side we use product rule. So ln x is 1 over x plus ln x. So we move the y to the other side, we will get 1 plus ln x. So y is x to the power of x, 1 plus ln x. So y prime will be equal to what we want to get, which is the derivative of y is the answer. So this is the answer. So let's try another example. Let's say we want to differentiate. Y equal to x to the power of e to the power of x. So let's say we want to always do the same. We take ln on both sides. So the first thing we do, we move the ex to front. So ln x, ln y. Then we do the same thing, we differentiate both sides with respect to x. So we know that on the left hand side we should actually use chain rule, which is what you get will be y prime over y equal to, on the right hand side, so on the right hand side you will get, you want to use product rule, so when you differentiate you will get ex 1 over x plus ln x, and this differentiate ex, you will get back the same thing. So the answer will be y is x to the power of ex, and you will get ex over x plus ln x multiply with ex. So now you want to rewrite it so that it looks nicer. So you will have x and ex 1 plus x ln x. So this is what you will get. Now we can actually try the last example. So let's say now we want to differentiate. If you want to differentiate y equal to sine x to the power of x cubed, so the thing that we do always is we take the ln on both sides. And we move the x cubed to the front. And we differentiate both sides. So we will get y prime over y equal to, we do product rule. So what we will get x cubed 1 over sine x multiply with cosine x plus ln sine x multiply with 3x squared. So you will get the answer as, so y equal to sine x to the power of x cubed multiply with x cubed times cosine x over sine x plus 3x squared ln sine x. So this is your answer. So if you have learned something new, and if you want to learn more about other mathematics topics, feel free to subscribe the channels, and you also can check out my other videos on product rules and also quotient rules, and also how you can actually do other kind of differentiations. Please check my playlist. Thank you.